Alright, so in our very last example for today, we're asked to find the number of terms and the sum. Well, I can't find the sum unless I know how many terms there are because the sum depends on that. So I'm going to have to explore a little bit. So here's what's going to happen in this example. I'm going to tell you that this is an arithmetic sequence. I'm going to give you the first 3 terms and the last term. So here are my first 3 terms. And then usually our last term gets separated by these little, the dot, dot, dot. And that means that this is the last term. So first 3 terms and the last term. I told you verbally that this is arithmetic, but if I wanted to check, I could find the common difference between these, and I would figure out that it's consistent. So basically, I know A is 1082, and I know that L is 2,916, and boy, this just doesn't seem like enough information because I know that since I have A and L, I need to use that last term formula, okay? But I also need to know D, which means that I am going to have to calculate the common difference, which happens to be 131, okay? Second term minus the first. Third term minus the second. So it's always the next term minus the prior. Okay, so D is 131. So as a reminder, if you're not sure how to proceed, you can kind of jot down the formula and then figure out what you need. Okay, so I'm going to go ahead and plug in what I know, like I did in the prior examples, and I'm going to solve for n. So I've plugged in everything I've listed above, and now I'm going to subtract 1,082 from both sides. And I end up with 1,834 equals 131 quantity and times quantity n minus 1. I'm going to divide by 131. And I get n minus 1 equals 14. So I'm going to add 1 to both sides. So that means, oh, my pen is really not working right now. Okay, so that means 15 equals n. Okay, not too bad. So now that I know n, I can add this to the list of things I know. I can go ahead and, ooh, that's a really crooked line. There we go. I can go ahead and find the sum. So if you'll remember, we know the first term and the last term, which means we get to use the shorter summation equation for arithmetic sequences. That looks like this. Okay, so since I'm finding the sum, I have to find S sub n. Okay, easy as that. Half times, I said my number of terms is 15, that's what we just found, times quantity A, which is 1,082. That's my last term, which is 2,916. If I put this into my calculator, I end up getting, oops, and I should have put 15 here too, by the way, because I know there's 15 terms. I know the sum of my 15 terms in this arithmetic sequence equals 29,985. Okay, so if we go back and have a look at our learning targets really quick. Oops. Okay, it says, have we found the number of terms in an arithmetic sequence or series? The answer is yes, in many ways. So you should be able to do those or be prepared to practice those in class tomorrow. And have we found the sum of a series or sequence when the number of terms is not given? That's the example we just did. So that concludes this lesson.